Welcome to 7.1 Interior and Exterior Angles. Let's start with thinking a little bit about a polygon. And if you were to take one vertex and draw as many diagonals as possible, we need to think about the relationship of the number of sides and the number of triangles formed by the diagonals. So let's look at some of these polygons that we cut using our diagonals. The first one, we have a four-sided shape with two triangles. A five-sided shape with three triangles, 6 with 4, 7 with 5, and 8 with 6. The idea is that it's the number of sides minus 2. So we're going to write an equation of that, and we're going to figure out what the sum of all of the angles of a triangle. So the angles of a triangle are 180. If there are n minus 2 triangles in the shape, then we can do 180 times n minus 2. And that is the interior angle sum theorem. So the idea is that you can do 180 times the number of triangles you can draw. So an example of this, a nonagon is 9 sides. So we're going to do 9 minus 2, which is 7, times 180, which is 1,260. So that's the interior angle sum. Next, we need to know what a regular polygon is. Thinking back to Unit 1, it's equilateral and equiangular, meaning if we know the total amount of degrees in a polygon, then we can divide by the number of sides to find out how many degrees are in each angle. So the formula is just that 180 times n minus 2, which we already know from the interior angle sum, and we just divide by the number of sides. So to see this done, this is a pentagon. It's 5 sides, so we're going to substitute 5n for n. We're going to do 5 minus 2, which is 3, times 180, which is 540, and then we'll divide by 5. And we get 108 degrees for each angle in a pentagon, as long as it's regular. Now we want to talk about exterior angles. So here are 3 exterior angles of a triangle. To find them, we do 180 minus the interior angle. To find 115 and 130 for our exteriors, we add them together and we find that in a triangle, the exterior angle sum is 360. So let's look at a quadrilateral and see if there's a pattern. Find all exterior angles, we do 180 minus again to find 71, 115, 75, and 99. When we add those together, we also find it's 360. So the exterior angle sum is just 360. There's no actual substitution to it, it's just a number. So to find one exterior angle on a regular polygon, we do 360 divided by n, meaning the number of sides. So here an octagon, we're going to do 360 divided by 8. And we find that one exterior angle on an octagon is 45 degrees. So our formula again is 360 divided by n. Finally, we want to look at a little bit more complex ones. We're going to have to use interior angle sum. This is not a regular polygon, so we can't divide by n. We're just doing that n minus 2 times 180. It's a 9-sided shape, so we do 9 minus 2 times 180 and find that it's 1,260. Next thing we're going to do is we're going to add up all of the angles in that nonagon. So we get 9x plus 37 equals 1,260. And here we have a normal two-step equation, subtract 37, divide by 9, and we get 135.9. Our last example, this is exterior angle sum. Well, the exterior angles add up to 360, so we're just going to combine all of our exterior angles. We get 9x plus 190 equals 360. Subtract 190 and divide by 9 and we get 18.9. So that is interior and exterior angles.